Alright guys, welcome to this page of the notes, and what we're going to do is we're going to begin working on that second objective or learning target, which is going to be simplifying expressions with rational exponents. Alright, so let's go ahead and jump right into this, and a couple of things to remind you of as we go through these problems. First of all, we're going to treat rational exponents the same way you would treat integer exponents. So all the properties that we know about exponents from previous chapters here in Algebra 2, they're all going to apply here. The only difference now is instead of having an exponent that is an integer, your exponent is going to be a fraction. Then, of course, don't forget all of the things we've already learned here in this chapter about simplifying radical expressions. And it's this: if you can get the index and the power to be the same, they'll cancel each other out. We'll work on that. And then the big one is you cannot have a radical in the denominator, right? No radicals in the basement. Everybody's got to come upstairs. So if you have a radical in the denominator, we'll use that technique of rationalizing the denominator to get the radical out of the denominator into the top. So let's go ahead and jump right into these and see how they're going to work out. The first one I want you to simplify is going to be x to the 1/5 and an x to the 7/5. Well, the reason I've given you this one is for this reason. The property of exponents says if the bases are the same and they're multiplied, you add exponents. So let's do that. This is going to be x to the 1/5 plus 7/5. Well, we know in order to add fractions, the denominators have to be the same. If the denominators weren't the same, you would go ahead and get a common denominator, which you guys know how to do, and then you would be able to add your fractions. I was nice on the first one, and I already gave you rational exponents with a common denominator, so now all we do is add the numerators, keep the common denominator. 1 plus 7 is going to be 8. So this is equal to x raised to the 8/5 power. But we can further simplify this. Here's what I know. The numerator stays the power. The denominator, the 5, will become my index. So I can rewrite this as the 5th root of x to the 8th. And what I had reminded you of was this. If I can get the index and the power to be the same, then I can get them to cancel. Well, 8 is not divisible by 5. But I can split the 8 up into something that is. I can split this up into an x to the 5th times an x to the 3rd and take the 5th root of all of that. Right? 5 plus 3 would be 8. So this right here is just another way of rewriting x to the 8th. But now what has happened is my index and the power are the same. So those will cancel each other out, and I'll be left with just an x times the 5th root of x to the 3rd. Now, there's nothing else I can do to this guy, right? There's no way of rewriting a 3 to make it divisible by a 5. There's nothing else I can do, and so we'll just leave it as the 5th root of an x cubed. Let's try another one. What I've got for you here is a y raised to the negative 3/4 power. Well, right away what should jump out at you is that your exponent is negative, and that's no bueno. We can change it to a positive exponent by taking it to the denominator. That's exactly what we're going to do. 1 over y to the 3/4. Well, let's rewrite this guy then as a radical, which I can do. I know the 3 is going to stay the power, the 4 will become the index. So 1 over a 4th root of a y cubed. Well, my next step then is going to be this. What I recognize is that I have a radical in the denominator, and that is not okay. So we're going to get to practice that technique we learned earlier in a previous section of rationalizing the denominator. And in that technique, the first thing we learned was you need to immediately check to see what the index is. In this case, the index is a 4. So what I'm going to do is multiply top and bottom by the exact same nth degree radical. Top and bottom will be multiplied by a 4th root. So let me rewrite it. 1 over the 4th root of y cubed times top and bottom is going to get multiplied by a fourth root. That's what the property says. Multiply top and bottom by the exact same root. But remember what goes inside. Your radicand is going to be the variable raised to the n minus x power, where n is the index, which for us is a 4, and x is the exponent, which for us is a 3. Well, n minus x, or 4 minus 3, would be a 1. So this is going to be a y and a y. You certainly can write the first power if you want to, but you don't need to. A 1 is, of course, implied. Now, what we do is we multiply, right? We multiply the numerators, multiply the denominators. 1 times the fourth root of y would just be a fourth root of y. In the denominator, right? Fourth root. So, since I have a fourth root in both, whatever my radicands are will all go under a fourth root. We'll just put them together. Well, I have a y cubed and a y. But whenever you multiply and the bases are the same, you add the exponents. 3 plus 1 would be a 4. So I have the fourth root of y in the top all over the fourth root of a y to the fourth power. What happens? Index and the power match. They'll cancel each other out, and I'll be left with just a y in the bottom. So this whole thing simplifies to a fourth root of y all over a y. There's nothing else you can do to that. There is no way to get this 1 to be rewritten as something that is divisible by 4. And so you're done here with the fourth root of y over y. Guys, head over to the next page of the notes. We'll practice simplifying a few more of these. I'll meet you guys there.